Hello, my name is Anna Molosky, and today I'll be presenting my final project for managing machine learning. My problem I focused on is online credit fraud prevention. Let's go. So first, why did I tackle this problem? There is a huge opportunity to regain revenue lost for credit card companies and financial institutions, as well as consumers. So in 2023 alone, there is an estimated 36.13 billion lost to online credit card fraud. So why ML to solve this problem? So this is very feasible. These credit card companies and financial institutions have resources and huge amounts of data that they've already been collecting. Every time a transaction occurs, many features and different information is collected about that transaction already. Furthermore, with these huge big data sets, manual analysis is impractical. Furthermore, we need a method that evolves quickly to detect and prevent new evasion patterns. So following the CRISP-DM business understanding framework, our target user, so the end user would be credit fraud analysts within financial institutions, look at these, kind of large dashboards and ultimately may make some decisions on whether it's fraud or not. The problem we already discussed, a large problem here that I cannot reiterate enough is that fraudsters rapidly change tactics. So this kind of rapid machine learning retraining is critical to this problem space. Why it matters. So if credit card companies don't prevent fraud, they lose money and ultimately customers. The current state, depending on the credit card company, some use ML, but a lot of companies as well just use a combination of simple rules-based systems, so kind of if-then and manual review processes to detect fraud. So with this problem, how do we define success? Our expected impact and also the outcome metrics be to reduce the revenue leakage due to online credit card fraud. Number 2, minimize time to identify fraud. And 3, increase the occurrence of true positives, which is the recall metric, measuring the proportion of actual fraudulent accounts that were correctly identified by the model. This is critical in scenarios where missing a fraudulent activity can have significant financial implications. So what our output would be, again, is that recall of all predicted values. Our targets are the outcome, the ability to correctly flag true fraudulent transaction increases by a certain percentage. And the output is recall is over a certain percentage, and also precision, which is the measure of the proportion of accounts or transactions flagged as fraudulent that were actually fraudulent increases. It's very useful when the cost of a false positive, so incorrectly flagging a legitimate account is fraudulent, where the legitimate transaction is fraudulent, is high, but it's not as high as missing a fraudulent transaction. The constraints, of course, are restricted access to detailed user behavior, data, and any personal identifiable information, PII, due to privacy laws and regulations that differ by jurisdiction. So here in the US, it's very different than here in India in the data storage laws. Moving on, what are some factors?
Factor.
Like we want to consider as our inputs into this classification model. One, so transaction amount, and transaction, and all these need to be compared to the customer's typical behavior, but it's common that high transactions, so very expensive transactions, are more likely to be fraudulent. Location consistency. So where are these purchases being made? Is it being made from the user's IP address or a totally different country where the person has never been? Also, does the customer have history with this online merchant? Transaction frequency. So that is just, is a customer making more online purchases than usual? So if somebody never uses this card or hasn't only made 2 transactions the past year, making 20 rapid transactions would definitely be a red flag. So a device. Are purchases made from a recognized device at the account level? So we can use the IMEI number from a smartphone or the MAC address of a computer. Account age also, is it a new account or an established account? New accounts are more likely to have fraudulent activity, and so they're monitored more closely. And finally, fraud history. Does this account have prior history of fraudulent transactions? If so, we'll look at that. Look at those transactions from that account with more scrutiny. All right. So, what is the machine learning solution? Where the fraud analyst can look at kind of a summary and any kind of trends of fraud over time, get warnings, that sort of thing. We have our data, which is the most important. So when within our organization, assuming we're a large financial organization like MasterCard or Visa, we have a ton of internal historical data. If we wanted to have some more data from a wider variety of sources than our customers, we could use Kaggle, which is an open source database, has a lot of different data sets about fraud, as well as the CI ML repository. For the model, chosen here, the random forest model, this is a classification model, and this ensemble method allows for processing this large amount of data. It's also going to be much more explainable to our end stakeholders. Alternatively, we could use a neural network, which is appropriate for these complex relationships, but good luck explaining it to a CEO. And then the infrastructure underlying everything for this, I would choose the cloud for reasons I'll discuss later, as well as using online learning and online predictions. So how would I validate this model and this ML system? So first, I'd start up with a mock-up UI using actual historical data. In my experience, I've seen that it's not that successful when you show your end user, which is the fraud analyst, mock-up with just lorem ipsum or false values. So here we can see if we're collecting and displaying the correct data, which is very critical. Second would be a simple heuristic model. So I could use a limited rules-based prototype to establish a baseline and limit the number of features, test 2. So third, we could use a simple decision tree model to run, which is a smaller subset of our data, and compare that to the heuristic model. This will be very useful for gaining buy-in for the ML approach, assuming our decision tree model does indeed outperform the simple heuristic model. Lastly, we would implement our random forest model. So we train this, compare it to, different variations, tune all of our hyperparameters, features, weights, things like that. And then finally compare that output to 2 and 3. This, of course, is a very iterative cycle between, on step 4. So, and even after deployment, tuning is never done. So why did I make these decisions? For the problem of detecting and preventing fraudulent online credit card transactions, the most critical feature is that the most critical thing about this problem is that the fraudsters are always very quickly adapting their behavior once they notice a fraud control. So say if we really weighted heavily and we relied heavily on large transactions are always fraudulent, then a bad actor could just as easily make a good amount of small purchases that equal the same amount, but our model wouldn't catch it. So I chose the cloud. Of course, we can assume internet connectivity since we're making an online transaction. We have a huge amount of data to store, and this data set is constantly growing with each transaction. So every time someone makes a purchase, this is a transaction linked to their account. And customers already trust their credit card company with a lot of information, so this is not a huge issue for most people. Online learning is the training method I chose because we need to adapt the model in real time with each transaction. And the environment is one, as I mentioned, that adapts very quickly, changes very quickly as fraudulent patterns do. Finally, for the prediction, I would choose online prediction because we, again, need real-time analysis and decision-making, whether to push this transaction that's fraudulent to a further review step, or we just let it go through without any kind of for next steps. Also, this online prediction handles extremely large data sets with potential risks. So first is data drift, where the statistical properties of the data change. This is due to frequent changes in fraudster behavior, as I mentioned in the last step. So concept drift is another huge one. So this is where we have changes in the relationship between the feature, such as transaction size, and the output predictions. So there are many new types of fraud that are coming up, as well as just in general, changes that influence user spending behavior, such as economic conditions, a recession. Next, so the latency could be a huge issue given the scale of the data set if the infrastructure, meaning the underlying cloud storage and compute, aren't scaled up pretty much dynamically as the data set grows. Finally, we have a risk in the feedback loop. So this means that false positives or negatives can be incorporated into our training data set. So this can be caused by manual data review errors, also as well as biases and manual fraud investigation processes. So if somebody is, not diligent, or maybe just always denies a transaction and says it's fraud because they are lazy and don't want to do their job, this is a bias, and we have a risk of that being incorporated to our data set. So kind of frequent cleaning analysis of the data, as well as training of our model is required. Thank you for listening to the project again, and if you'd like to connect with me, go to linkedin.com/in/Anna Miloski. Thank you for your time and have a great rest of your day.